All right, Algebra 2, welcome back, guys. We are now moving into section 3 today of chapter 6. This is all about dividing polynomials, okay? So that first note right there, you guys remember doing long division back in elementary school, all that fun stuff? Well, it's coming back, all right? We're going to be doing some long division today, except it's with polynomials and binomials and all kinds of nomials. All right. We're also going to be using a different method besides long division called synthetic division. Sounds a little bit kind of like science or chemistry there. It's not, but that's what we're getting into. All right. So make sure that you guys are always taking the time, watch the video, take the notes. That's why we do it. All right. And if you have questions, ask in class. All right. Send me an email if you really have to have it answered before school, but ask those questions in class. All right. So long division. All right. There's really only like one time where you have to use this long division. By one time, I mean like one style. All right. And what are we talking about when we say style here? It's when the coefficient is 2 or more. And this is what I'm talking about. See how that's a 3? So again, coefficient is 2 or more. That coefficient right there, that's what we're talking about. In the divisor, fancy word, if you don't remember what divisor is, just remember that the divisor is going to be the binomial when we're doing these long division problems. All right, the polynomial is going to be the big one. The binomial is going to be the small one. So we're looking at a coefficient of 2 or more for the binomial. Then you will be using the long division method. All right. Now, when this video is done, I think you're going to prefer the synthetic division method, definitely a lot more. But there are times when synthetic division is not going to work well for you. So long division, when the coefficient binomial is 2 or more, all those things that we circled there, that's when long division needs to happen. All right. So here's the page talking about long division. So that's like a blurb from the book. All right. So it's going to give you a nice worked out example problem. But I wanted to make sure that you saw this part right here. This is important. And so go ahead and copy that down right there. Because if you're given a polynomial and it's not going in perfect descending order by way of the exponent, so in other words, the biggest exponent is first, and it has to go perfect descending. Like if it has 3, 2, 1, then a constant, that's perfect descending order. But let's say it goes 3, 2, and then constant, and we skip that 1, then that's where this part right here is very important, because you have to fill in that blank or missing term with a 0. And that is this guy right here. All right, so take the time to look at that, read that. That's only if the polynomial, not the binomial, the polynomial, remember the polynomial, that's this big part right here, if it doesn't go in a perfect descending order. All right, so let's do an example problem to show you the long division method. All right, okay. So what you'll notice is this is what's given, and I've taken the time to just go ahead and over here, you'll see, rewrite it in the proper way to start the problem. Okay, so the binomial always goes on the outside, the polynomial is going to go on the inside, and then we can proceed with the problem. All right, so what we're going to do first is we're going to take the first term under, which is the 15x squared, and we're going to divide it by the first term that's outside. All right, that's step 1. And what we get here, this is going to be 15 over 3, which is 5. And then the x's, we reduce those, drop down to just 5x. This is going to be the first part of our answer. Okay. So we're going to be putting a 5x right there. So that's step 1 for long division. Take the first term under, divide it by the first term out, and then what you're getting is the first part of your answer. So I like to think of it as you got the first divided by the first is equaling the first part of your answer. That's step 1. Okay, now step 2 is take what we just created, the 5x, and multiply it by the entire binomial on the outside. And that is going to give you what goes now under right here. So 5x, we're going to get 15x squared plus 5x. Now, take a little pause. Notice how we have a 15x squared, and there's another 15x squared directly below it. So this is one of the ones you were given, but you just created another one. If you've done that, you're doing it the right way. If you do not create the exact same number underneath it right there, something went wrong. So that's a little checkpoint that if you don't have it, something's wrong. Go back, redo. If it is the same, you're doing it the right way. You should feel pretty confident to keep proceeding. All right, now the next step is subtraction. And I like to put that in parentheses to make sure you know it's subtracting the whole thing, because we want these first terms right here to drop out, leaving us with just one term left over. In this case, 5 or 8 minus 5, giving us 3x. And then you remember long division in elementary school, bring down that next term, minus 12. All right, so I'm going to put a little 3 and then subtraction. Those are the same 3 steps you're going to do every time. Now redo it. All right, so now what we're going to have here is you have a brand new first term. It's the 3x. All right, so we have a 3x, and we will be dividing that by itself, which is kind of nice. 3x divided by 3x, in this case, just equals 1. All right, so then we're going to be writing a plus 1. All right, and then what do we do with that 1? We multiply that 1 by the entire binomial on the outside. It's nice. 1 times anything is going to be itself. So we're writing 3x plus 1 underneath here. And then again, subtraction as our third step. Notice how we have 3x and another 3x below it. We're doing it the right way. That's our checkpoint, right? They cross out. A negative 12 minus 1 gives us a negative 13. Notice there's nothing left to pull down. So this is our remainder. So our remainder is now going to be minus, and then we're going to say 13 over binomial on the outside. So this right here is the solution. All right, so that is just a full walkthrough of how to do the long division method, which again, you only really need to do the long division method when you have a coefficient of 2 or greater. That was a 3, so we had to do it. All right, let's look at synthetic division. So synthetic division is a lot easier. It's totally different looking than the long division method. And this is what you're going to use when you have no coefficient with that first term in the binomial. Okay, so that's this guy right here. When the divisor is just x minus a, or just x minus a number, or x plus a number. Now what you need to pay attention to though, see in this example problem how it says minus a. Look over here how it says plus 2. But look what we put here was a negative 2. That means that if in the binomial it says plus a number, you have to change the sign and make it a negative. If it says it's already a negative, then it's going to be a positive. All right, watch as we do those. And we're going to do synthetic division here pretty soon. This last little note is for the third style of problem. If they just say evaluate the polynomial, simple enough. Plug in the given value, solve the polynomial. I've highlighted the most important part of those notes right there. And this is going to be basically plug it into the calculator, work it through, you'll get your answer very easy. All right, let's do an example problem with synthetic division. Okay, so the first thing you notice is that we have a plus 3 right here. So when we set up synthetic division, you're going to have this little box go right here. Notice it says +3, so we're going to put a -3. Then you have to put the coefficients lined up next to this. 6, -5, -6. Let's put our line down here. Okay, and then step 1, this first term always drops straight down. So that 6 drops straight down. Now what you're going to do is you're going to multiply -3 times 6. All right, -3 times 6, giving us -18. Okay, and then we are doing addition, always off to the side. Go ahead and put that in there. Now a -5 plus a -18 going to give us a bigger negative of -23. Okay. And then you're going to take the -3 and multiply it by the -23. And that's now going to give you -69 and -6 and -69, giving you, wait, was that? Oh, should have been a positive. Just figured out that mistake right there. That should just be regular. Negative times a negative should be a positive. Almost had a huge error right there. Okay, so that's actually going to give us 63. And that's going to be a positive 63. So now what you possess here is you have all of the coefficients and the constant term. And now we're going to take these values and create the polynomial. So that's a positive 6 in front. It's going to be 6x minus 23 plus 63 over x plus 3. This is a much faster method. Of course, it only works when right here you're dealing with no coefficient. The next thing I want you to notice is see how we had a squared here, and down here we're going to drop it by 1. So if we have a squared in the problem, in our answer, it would only be a 1 coefficient. If we had a cubed in our original problem, we'd have a squared in our answer, and it would always go in that perfect descending order. Okay, let's do one more problem here with synthetic division. So now you see how we have a -6. So that means we're going to now have a positive 6 in the little box. And let's write the coefficient. There's a 1, a -3, and a -18. All right, how did we get those? There really is a coefficient of 1 right there. That's how we got that. There's the -3 going there, and the -18 going right there. Okay, let's do our line. And then the 1, whatever that first one is, it just goes straight down. 6 times 1 is 6. Don't forget all of this. We are using addition for this. So a -3 plus 6, giving us positive 3. 6 times 3, giving us 18. And that one working out perfectly with a remainder of 0. So when you have a remainder of 0, we're not going to have this kind of this weird fraction at the end. So all we're looking at here is simply x plus 3. That is it. All right, so that 1 translates to just x by itself, positive 3 plus 3. That one worked out very nicely. All right, and what we have here is our very last example problem. Simply use the calculator. Okay, but one thing I'm going to tell you guys is when you have fractions given, always put the fraction in a set of parentheses. So when you plug this into your calculator, this is really how it should look. All right, you're going to have a set of parentheses, then you're going to have a 5, then another set of parentheses for the 1/5, close it, square that, and then close it again. If you're plugging it into the calculator and you want to make sure you get it right, that's the type of details you have to plug in. Then do a plus sign, then another set of parentheses, 9, another set, because you want the calculator to understand that 1/5 is a fraction altogether. And then plus 3. If you plug it into your calculator just like this, with all those parentheses, everything should work out to just getting an answer of 5. Okay? All right, guys. That covers everything you need for section 3. Take the time, copy the notes. You have questions, ask those questions. All right? We'll see you guys in the next one.